Hello, everyone. Today, I'm going to be talking about our ECE 460J Data Science Lab final project. Our final project was Pokemon Showdown with reinforcement learning. So I'm going to go through how we did it and how to do it yourself, actually, as well. So step one, we also have an article on this. We're going to go to the repo, and on the repo, we're going to find some commands that we can run. So the first thing we're going to do is we're going to actually just run the commands. So I've opened a new folder, and I'm going to open up a new terminal inside this folder. And inside of here, what I'm going to do is I'm going to call the first command, which is going to just clone the repository. And let me clone it real quick. All right. So, okay, now that it's finished, we have to do the next part, which is going to download the actual Pokemon Showdown server. So once again, you can find it on the GitHub. I'm just going to paste the commands, but what this will do is go clone the Pokemon Showdown server, install the packages for it with JS, and okay, wow, it's done. Okay, so now the next thing we can do is we can actually just create the Python environment, and the Python environment is going to include packages like Gymnasium, PokeENV, which we're going to use that simulates the Pokemon environment, connecting it to Pokemon Showdown, as well as TensorBoard, and stable baselines for the RL algorithms. So yeah, let's let this thing download and we'll be back. Okay, so everything just finished installing. Now I'm going to open up the folder. So here we go, example, PokeRL. All right, let's quickly go through some of these files here so we know what we're working with. So first of all, we're going to go to RL train. So this is going to basically be a simple script that trains the models. So what we have is we have a model directory and a log directory. These are just going to be for us to actually check the performance of our models and actually save them as well. This is just code to basically create the folders for them. And we're going to have all our players in a file called agents.py. So I just did basically a superclass of all of them just to make it my life easier. Doesn't have to be like that way. But here we have simple RL player 0, which can be found on the GitHub. And it was basically from the PokeENV area. And then here are some of our own takes for simple players that are slightly different, that basically include different states for the state encoding for the embeddings and have different reward functions. For example, this one doesn't actually use the HV value to compute the reward while the normal one does. So I'm going to quickly go through how to basically run some of these, right? So what you're going to want to do is you're going to want to basically set up the Pokemon Showdown server. Now, how do you do that? Well, there's a command that can be found on the GitHub repo. Basically node Pokemon Showdown start -- node security. Now, this won't work unless you're inside the Pokemon Showdown directory. So here you're going to see it basically did nothing. So if you basically change your directory to the Pokemon Showdown directory and then run it, you're going to basically see this little message from the server. So worker 1 is now listening, but you can test your server here. So now if I just control click that, what you can see is actually the Pokemon Showdown server. Now, what can I do with the server? I can basically look at the battles, team builds, basically the actual like website features, and you can basically choose a username, which we can do later whenever we want to play against our RL bot. But this is where all the battles are going to be taking place. So if I'm going to make our simple RL player play against the max damage player or the random player, I can actually see the recordings here. So let me switch back to the code itself. So the code itself, I'm going to continue. These are the agents. So RL train generates those folders, and here we specify the actual model being used. So for the Gymnasium environment, we reset the battles, basically clear the environment, and we specify the model we use over here. We're going to use A2C, but you could change it to PPO, you could change it to DQN as well. So you can change those to whatever you want, and then we can make it basically learn through this model.learn function for a certain number of time steps. This reset time steps, nums time steps, is basically for us to remember in the model how many time steps it's been trained for whenever we're saving it. And we can just save it. So this is going to take forever to run if you were to just click run right now. So I'll probably run a few samples off screen just to show you what it looks like, and then I'll show you the actual examples to see what we can do with these outputs. So the way you can run it is first you go into your terminal. I'm just going to use command prompt, and then make sure you're in your virtual environment. So the way you can do that is you can just go to your virtual environment, go to scripts, and then type in activate, and you should see a little .env over here. And now you can basically just run python rl train.py, and now it's going to basically start training. And the way you can tell, there is no actual message here. The way you can tell is it's going to generate some folders on the left side. So give it a quick second, and it should, yeah, right here. So it'll start slowly populating them with the models it creates during training. I'll get off for now, and I'll be right back as soon as I get a couple logs to show you what we can do. Okay, it's been running for a while, so I'm just going to stop it right now, and let's look at the results. So just going to Control C, and then actually just close the terminal as well. And then we can actually just quickly see some of the training inside the actual server. So let's say if I were to open a Pokemon Showdown right now, you can actually see basically right here all the real battles that's been played whenever it's been training. Okay, so yeah, let me just connect here as well. But now that that's done, I wanted to show you the actual TensorBoard output. So in order to actually use the TensorBoard output, what that is basically you can actually see the reward as a function of the number of training periods it's done. So let me pull it up right now. So the command is inside your Python environment. So make sure you're in your virtual environment. So let me do that again real quick. Okay, the command is basically TensorBoard -- logger equals the folder name. In our case, it's going to be logs. So if I click enter, we can actually just let it run. It'll give us a link or a URL that we can go to. And then let me show that on screen. Okay, so we have the episode reward mean. That's what we're really interested in. And as you can see, at around, I guess, since we're only saving it at 10K intervals, I'd say about 80 is our best model. So we want to keep that in track. So 80K is a good place. So let me go back to the editor real quick. Let's close this and test it against some of the other models. So here, let's just change this to our 80,000. So 80,000, and let's try running this script. Okay, so we're going to see how well it does against 100, in how well it does when it's doing 100 battles against a random player and one that's doing max damage. So we can just do python rl_test.py and enter. This might take some time to run. I'll be right back. Okay, I had a little hiccup before I cut. I forgot to turn on the server back on. Now that it's back up, we won 94 battles against random player and 58 against max damage player. That's pretty cool. But I actually want to play against this thing myself. So let's do that, right? First, actually, let's just show you, let me just show you how to pull up a replay during this battle process. So what you can do is you can go to the URL for your server. If you just open that up, you'll be in here and you can just go select any one of these and then click instant replay, let it run. So, and I also recommend turning off sound. It's too loud for you, but yeah, we can basically just see it playing each turn. Okay, now I actually want to play against my model, right? So what I'm going to do is I'm going to quickly just temporarily shut off the server and then turn it back on. So Control C, turn it back on real quick. And then I want to run this rlplay.py file. And you're going to want to change this to whatever your best model was. Mine was 80,000, so I'm just going to keep it as 80,000. And in my virtual environment, I'm just going to run python rl_play.py. And before I do this, before I run this, I'm going to quickly make sure I choose my username on the website. So what I'm going to do is, let me pull it up right here. I'm going to reconnect. And on the top right, you're going to be seeing a way to choose your username. So tomatoes are better, choose the name. Make sure they match up so it knows where to send the battle request. So now we can run the Python script, right? So in VS Code, I can just run enter. And now this is going to send me a challenge. So if I go back to Chrome then what I can see is, look, on the top, on the left side, accept. All right, let's play against our RL player. All right, so I'm gonna use Hydro Pump. Okay, I may have one shot. All right, so you know what? Let's give it a chance. You know what? Let's try doing Heavy Slam or something, right? Let's see what it does. Okay. So, as you can see, there's a lot of room for improvement, at least with this model, right? So, the thing about this model is that it actually doesn't take into account any status conditions. It also doesn't have access to the health of each Pokemon in the field whenever it's doing its context in terms of the embedding. And there's basically a lot more other things it just doesn't have information of. So I'd say this is a pretty good start for knowing what it knows, which is the number of Pokemon that are on both sides that are fainted. It also knows that the amount of damage that each move does, and two more things. But pretty good, I would say, for only that little information. So let me show you how to pull up the examples that we have. Okay, so let me quickly just close this right here, and let me go back to VS Code and just stop the server and the Python script. So I'm just gonna do Control C, Control C. Okay, so basically you're gonna see an examples folder, right? This examples folder contains a couple models, it contains a couple logs. So these were trained for a very long time, like a really long time. So we can actually just pull up the tensor board for them. So let's just pull that up real quick, right? So the way we do it is, I'm just gonna close the terminal real quick. You wanna open your environment, set up your virtual environment. You're gonna want to, after that, run TensorBoard, and with the -- logdir equals, and we're gonna do examples / models _ simple bar0. Actually, not models. We're looking at logs, so we want to change this to logs, right? So if I just run that, then in the episode reward mean, you can see that we ran this for like 666,000 training steps, and we found out that the best one was at around what I believe was 260K. But yeah, and those are basically, that's the model we've attached. And so if you want to run this model for yourself, what you can do is just change the model directory so that instead of going to models, into the models directory, you can just change it so that it goes for models and then / models _ simple R0, and then just change this value to 60,000, and you should be able to play against it yourself, just like the other ones. But yeah, that's all we have for you today. I hope you liked our project. All right, thank you.